Hi. So in this video, we're going to talk about vectors, okay? And vectors are something within maths that maybe we've not heard of before. If you are studying physics, perhaps you do use these quite a lot already, but this is the first time that we're using them in maths. And what a vector is, if we go through some definitions firstly. Scalar is another word we're going to learn today. Scalar is a quantity that can be represented by magnitude alone. And we see here, I've defined magnitude as well. Magnitude is the numerical value of something's length, size, or quantity. So in quick ways, magnitude is its size. So a scalar is a quantity that is only got a magnitude. Okay, so it's just a quantity, whereas a vector has a magnitude, but it's also got a direction. So it's got a route. And so what I've done to hopefully explain that better is give you some examples of what are considered scalars and what are considered vectors. So a scalar is an object mass. Okay, so if you think about mass is the quantity that you are, like so an object, it's the quantity of your calculator, or it's a quantity giving how much weight there is, mass there is with that object. But however, when you put that object, say, on the earth, gravity forces it in a direction, so that mass then becomes weight. Okay, because gravity affects you differently on Earth as it would do on the moon. So this object, this calculator, will have the same mass no matter what, but it'll have a different weight on the Earth as it does have on the moon. So therefore, because the direction is pointing it to the ground, and it's giving it weight is a vector. Okay. Another example could be an object's speed. Depending on how fast you're going, you will certainly be traveling on your way somewhere, and you'll be going at a certain speed. And I guess the best way of explaining this is if you were to describe your speed, that's all very good, but unless you tell me what direction you're going in, I have no idea where you're going. And so the word for speed with a direction is velocity. Okay. Another example could be energy. So I am going to push onto this button with a certain amount of energy. The quantity described, because I've pushed in that direction, there's force being applied to the calculator. I gave it a certain amount of energy, but the vector, which is a scalar quantity, however, because I've done it in a specific direction, it then becomes force. Okay. Another one could be distance and displacement. Distance is a quantity of I've travelled this much distance since this morning, whereas displacement would be how far I've travelled in a specific direction, say from an origin, from say I left my house and I went to Liberton High School, I've gone there in a specific direction, so that is the displacement of me from my house. Okay. And then time is a scalar, so the concept of time is a scalar. There isn't really a vector representation of that because time is just happening. And so hopefully that's explained what vectors are, and now that you've learned what they are, we're going to talk about the notation that we use for them. Okay, so there's different ways of representing a vector. I can do it graphically, I can do it numerically, and I can do it with letters. Okay. So hopefully what you can see is I've got 2 points here. I've got the point A and I've got the point B, and hopefully we can see that this is a vector because it's got an arrow. The arrow is showing the direction of the vector, and then it's got the 2 points A and B. So imagine that's my journey, like I was just saying. That's my house, that's Liberton High School. I've gone in that direction. So it's got a quantity and it's got a direction. We can represent that as the 2 letters A to B, with the arrow going from them because we're going from A to B. Another way you could represent it is it's the negative of the reverse journey. So it is the negative of B to A. So it's the opposite journey. We could also use these smaller lowercase letters with a line under it to represent vectors. Sometimes they could be represented that. I've decided to describe it as U. And then lastly, we can describe them numerically. Where have this 8 and this 4 come from? Well, if you check here, I have gone 1, 2, 3, 4, 5, 6, 7, 8 boxes along, so 8 units along, and then 4 units up. And so there is where you get 8, 4 from. And we can call that the column, spelled column wrong, column vector. And even though it just looks like it may be coordinates, it's not coordinates. It's the distance 8 and then 4. I've not related this at this point to a coordinate diagram. So it's a distance of I've travelled 8 along the x-axis and 4 along the y-axis, but I've not told you where I've started in relation to an origin. So a vector, you could have this vector here, 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 here. It's still 8 and 4. So another version could be this vector st. You can see here the arrow is pointing this way, which means we're starting at t and going to s. So that's why I've done ts with the arrow above it. Or I could do it the negative journey, negative s to t. Negative because I'm going against the arrow. I've decided to call it w, so there would be w here. And then again, I'm starting at t. Now, I'm going backwards along the direction of the x-axis, so it's -9. And then it's 3 in the direction of the y-axis. So that's where the numerical vector comes from. And this one here, again, the vector is going from p to q, so it's p to q, or we could think of it as a negative qp. And again, it is going 6 along in the x-axis. 1, 2, 3, 4, 5. No, I'm not. I'm going 5 along the x-axis, and then I'm going 1, 2, 3, 4, 5, 6. 6 along. So I got them mixed up. So I've gone 5 backwards, and then 6 down. So when you're going to the left or down, it is negative, and when you're going to the right or up, it is positive. Okay, so do a few examples. Express the following vectors numerically. So I'm starting at A, check the arrow, I'm going from A to B. So it's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's 4 along and 5 up. I'm going from C to D. So we're going to go 1, 2, 3, 4, 5, 6, 7, back, and then 1, 2, 3, 4. So it's -7, -4. Express the following vectors graphically. So we've got the vector A, and it's starting 2, going along 2, and then it's going up 5. So it doesn't really matter where you start, as long as I go along 2, and then I go up 5. So 1, 2, 3, 4, 5. And then we can draw that. Make sure you put your arrow, and there. Make sure you get your arrow actually on the line. So that's me expressed that graphically. Do another one. It's -7, -3. So it doesn't really matter where I start, but I'm going to start in a central place which means I can finish it. So I started over here. I'm going 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 backwards, and then down 3. 1, 2, 3. So we can draw the line between them. Make sure you draw your arrow, and then that is the vector B. So that's an introduction to what vectors are and the notation and how we describe them.